Hello, everyone. Hello, team. Uh,
Welcome.
Thank you. Nice to meet you all. I think that not everybody here knows who I am. So, my name is Juan. I'm a developer from Brazil, and I work mainly on Photon Quantum. I'm the lead developer of Bot SDK, which is our deterministic, data-driven solution for having AI in games with Quantum. And I also help with the team management currently. So in today's stream, we are going to showcase a new quantum sample that we'll be releasing early next week. It's called the Twin Stick Shooter sample, and it's basically very much inspired by Brawl Stars because it's a game that I like, and I felt that we should have some more intermediate to advanced AI sample with Quantum, as I'm the lead developer of the Bot SDK. I always felt that this was something that we were missing. Of course, the sample will not be delivered on the initial state with everything already built in. We're starting with a state machine presentation, then we will move on with behavior tree, utility theory, and GOP, etc. So we're here just to showcase the sample so you know what is coming on. And for those who doesn't know Quantum, you get a chance to see a little bit of how it looks like on gameplay. And for those of you who use Quantum but do not use the Bot SDK yet, you get to see how it works, see the basics of it, and perhaps ask some questions if you feel like it. So just to start, let's begin with the actual gameplay, just so you know what we'll be talking about. Let me switch here to the gameplay scene.
All right. So, which character are you going to be playing as today? I see Ramon and Juarez already choosing knights and mages over there. What's the best counter?
Well,
I'm sure you have some inside tips here on how we could best beat them.
Sure thing. So the mage is very good for fighting behind walls. So we need a way to get that mage from Juarez. So the best way to actually get it is to either counter it with a mage or with a knight. So you want to be one of those.
Perfect. I haven't played as the knight yet, so let me take that one.
Yeah, so he's fast, so you can chase Juarez behind the walls while I try to deal with Ramon. So we have 4 players here, and we will also have 2 bots joining us, just so as a sample on how to fill a room with bots if you don't have enough players, which is something important for some games, or most of them. So let's go, just play. It can be confusing at first, but I'll try to guide you all on the process. So this is the coin grab mode. We basically have to get the coins on the center of the map. And here's my character, it's the archer, so I can basically hold the attack button to show the prediction of where my attack will go into. So this showcases basic projectiles with Quantum, with delta ray casting for the actual collision logic, so we don't miss. We don't allow any tunneling to happen if the projectile is fast. We also have the special attack, which I have to charge by landing attacks on other people. And here, as you can see, we have 3 types of characters. We have the archer, the spellcaster showcases a little bit of ballistic projectiles. Again, this is a 2D game, so there is no actual y-axis here being used. So the ballistic is just a faked interaction with the view and the simulation part itself. So this
that's actually an interesting point as well, because keep in mind, most games have 3D just as a visual, so we don't actually need necessarily for gameplay the third axis. We can't just have that for, well, the visuals.
Correct. And so it can be very handy for you to make those decisions. So if your game is 2D, it doesn't mean that you cannot have stuff going above the walls, etc. So we just need here to collect 10 or more coins. Then we have this timer. It's 50 seconds, and once this timer is over, we will win. But of course, if you die, you will lose all of your coins. So you have to survive for 50 seconds with your with your coins. Okay, so we just need to survive. So again, we have 2 bots here. Not sure if you guys notice like who is the bot or not. Well, judging by the names, you can maybe tell it, but yeah, we have 2 fellow bots here. So that's it.
Are we the left team?
Yes, we are the left team, and we won.
Oh, so it's 10 coins in total between the 2 of us, not 10 coins for 1 person.
Yeah, no, it's in total. So the team sum up their coins, and then if it's 10 or more, you get to win. So that's it. That's the gameplay itself. This is the sample that will be releasing soon enough. And today's Fireside chat will be just basically show the overview of what is happening here. It will be mostly done with diagrams and on the Unity scene, just so we can give a step-by-step understanding on what can be achievable with Photon and with the sample. Okay, so let's get back to my computer here. Let me just find it here. Okay. This. Okay, so you can see my screen, right?
Yes, we can.
Perfect. So this is the Unity project. It's a quantum game. And here we have the basic setup. I'm not going to deep dive on everything here, but just to showcase a few things, we have this map and it has all of the colliders set up there. And just to showcase a little bit of our characters, here on resources, we have all of the possible characters that are playable. So we have the archer, we have also the knight, and the spellcaster. So basically, on Quantum, we have this whole entity prototype stuff that I'm not going to deep dive here, but I just wanted to show you guys that this is the composition that we have for every character that you saw there. So we have a KCC, so they know how to move. We have a player link, so they know to which player they are linked to. And we have the health component, so it's very granular. So it's an ECSE architecture, and we have the micro components, and we have microsystem to manage all of those things that every character can do. So we basically have a different setup of these characteristics per character. So for example, let's see here the attributes, which we have a specific architecture with dictionaries to create more flexible attributes and modifier stuff. So for example, the spellcaster has 3000 health, while knight has 6000, etc. So it's basically stuff that we define on the quantum side, on the simulation side, that we can tweak right here on the Ester. So that's basically it for the characters. We will have more as we release updates on the game. And besides of characters, we also have a very much data-centric, asset data-centric architecture for attacks. So you define attacks with entity prototypes and scriptable objects with Unity. We have a dynamic way of telling, okay, so when this attack lands in others, what does it do? Does it sum up? Does it subtract something? What attribute does it affect? So is it health, energy? So it can also apply things on the owner of the attack when it lands. So it will charge my special bar whenever it hits. So we have this very much data asset thing for the attacks and other stuff also. So as you can see, it's very much data driven. That's my, let's say, preferred combination currently, because I developed Bot SDK with the guys, the team, and Bot SDK itself is very much data asset based. So just a quick view here on how the AI on the Bot SDK looks like. So
well, actually, if you don't mind, before we dive into that, so we have talked about the entity composition, but of course the entity composition is only the elements that will drive the game state and the behavior of these entities, in this case the playable characters. But how does it look like, or how is this composition tied to, well, the visual representation that the player will actually see on screen? Since we discussed before already that although the whole gameplay is 2D, the visual representation is 3D. So what are some of the links that you have built here to combine these two aspects?
Yes, that's a nice question. So basically, with Quantum, we have some ways to represent entity views. That's how we call them. And within an entity view, it's a Unity component, so you can do all of the Unity stuff there, even though not all of the Quantum stuff, because you cannot write to the game state from the view side. So the view side will basically read the game state and know how to react to that, showing, for example, character animations and stuff like that. So just to exemplify, we have this entity prototype here, which is the Archer, and it has the entity view, the game entity view, which is a custom component that we built on top of the default entity view, just to add a few more functionalities. So we have the character view also, which will have some character-specific logic for showing view stuff. So for example, we have here the immunity VFX. So whenever you respawn, you're immune. So to showcase that you're immune, we have to activate it here. So the character view, which is a Unity component, will read something from the game state to know, okay, it's time to show the players that this is happening. So it's very much based on Unity components that you link somehow with Quantum data. And just to exemplify the ballistic projectile, let me find it here. It's a spellcaster ability.
And here again, we really need to emphasize one thing, is because of the determinism involved in Quantum, it is really not possible for anything of the Unity side components to write to the game state. Here it is strictly reading from Quantum. It is not about writing to it for the view.
Yeah, so that's make it super, super hard for hackers to try to change it. So okay, they can try and change something from Unity, but then this would just get their game to be undeterministic with other games, and basically they will drive their game state, and well, that's gonna be affected, not gonna be affected. So basically, can protect the simulation with code, knowing that from Unity nothing will ever be able to be changed. For example, if somebody tries to increase their speed vector to be very, very fast on the game, you can just, on the Quantum side, let's say, normalize that. So once you normalize it, people will not be able to change it again because they will be only touching them from Unity. So you can protect against cheats because from Unity, you cannot do much to the game state itself.
Right. Well, thank you. That was really insightful once again. But how about we go back to AI, which is everything that you know here specifically?
Yes. So this is the bot SDK window. It's basically bot SDK currently have 4 AI models inserted into it. We are planning for a 5th one that we are not going to talk too much about it right now. But basically, if you click here on the Create button, you have the HFSM. This stands for Hierarchical Finite State Machine. We also have the behavior tree. We also have goal-oriented action planning and utility theory. So it's very complete because when dealing with AI, you essentially will be trying to match up lots of tools that you have to take care of every part of the AI that you want to be taken care of. So for example, you can do part of the AI with a state machine, but maybe some decisions can be done better with the utility theory because you want to represent stuff with curves instead of hard thresholds. So you can use utility theory. Maybe for some boss, you do not want a state machine, but rather a behavior tree because you wanted to have a very sequential and specific execution. Or as people like to say, I want something that can be more easily emergent, like great immersive behavior. So that's a nice bet for GOP. So that's bot SDK. It has all of those. We want also to add machine learning, but we're still evaluating this. So with those 4 possibilities, I'll just showcase real quick creating a simple state machine. So it starts with this, and then you can create links to other states. We can rename things here. So this is the main state, for example. And then we also have the transitions. If you deep dive on transitions, you can define the decisions to know, okay, how does this, how can I go from this state to this one? Well, it depends on the conditions. So you have here a set of conditions that you will create with your quantum code, and then you just link it here. It can be composite. So for example, you can have a end, and it can be, okay, I'll transition to that if this condition and this condition evaluates as true. So, well, and this is another state machine. Like, for example, I can dive into this machine here, and then I can create more states. So this is where the hierarchical words comes in, because you have the hierarchy of states, and then you can create a very deep HFSM, and it's nice because you can encapsulate the substate machines for what you want to do, which is sometimes very, very helpful, because if you have to do everything on a single layer, then you will have a very big one single layer, and this can be very much hard to maintain and to proceed with. So this is basically the HFSM. And let me show you the player replacement HFSM. So as you saw, we had two bots playing as players on that match, because we are only for human players here. So we had two bots, and for those bots who replace players, we have this HFSM, which it's basically starting with a main thing where it can be in many states. So this is the way that I decided to do it. Of course, it can be done in many, many different ways, but essentially every bot will try to be on a tactical execution at every moment. So for example, my tactic can be I am engaging, or maybe I am running, I'm taking cover, or trying to collect a collectible. So depending on my tactical decision, my main state machine will be basically transitioning to one of those main states. So I can, for example, if I deep dive here on engage, what do we have for engage? We want to, on the update of this state, we want to be following a target to a certain distance. Once we pass that distance, we'll try to evade his attacks. Or if it gets too close, like 5 of distance, we'll try to run away. So we're always trying to get and to run from that target. And while we are doing that, we are also executing the substate machine, which will be useful for us to aim our attack. And then we release attack actually trying to hit someone. And once we do it, we will either go to a small delay, which is basically a random delay decision. So you can also do randomization and waiter and timers, etc. Or we will maybe decide to recover our energy, because if we have too less energy, we want to wait more time before actually engaging again. So it's a 5-time recovery. This is interesting also here because there is this whole configurable panel that you can create constants. You have the blackboard variables, also events to help you drive the state machine. Configuration, which is also very important because the configuration here is the default one, and then you can create sub configs for specific characters and just change the values. So it's very useful for creating, for example, hard mode AIs. They have a reaction time which is way much smaller than a easy mode AI. So you can just use the same config and change the value. So I'm not gonna deep dive too much on this yet because I want to do it on another stream. We'll have a exploration of this HFSM here, just so we can deep dive on the details. But the objective here was just to show you a little bit of how the state machine works here. And this is the responsible one of the parts that is responsible for the boss behavior that we saw in the build. Go on.
So yeah, we have a couple of questions here. And if you don't mind, I will start with like the simplest, and I dive down a bit before we move to the next subjects here. And the first one that was already answered to an extent in chat is this bot SDK. Is that an add-on to Quantum, or is that a custom plugin for Unity? Is it both? A bit? None? How would you best describe that?
Well, it's kind of both, but it's more content specific. I mean, we do have this visual editor, and it has an API that we code with that allows you to create this stuff on Unity, but it's not available to do anything Unity, let's say, because this specific build, which is for the bot SDK, it is tied with a lot of stuff that makes it specific to Quantum. So you can, for example, if I right click here, we have actions, and those actions are actual quantum assets, meaning that this is all quantum. So it's not, let's say, I can do anything Unity with this. It's not that. It's much more quantum specific.
All right, cool. So there's another thing. Of course, you showed us a couple of layers and how you could basically, in the case of the hierarchical finite state machine, as the name indicates, have a hierarchy. But the chat asks as well, saying that you had originally mentioned that there were some layers of AI for the sample. So I'm not sure if they are meaning different layers where, as you explained at the beginning, you'd have utility theory and behavior trees, or whether it would be layers that are more separated, where you would switch between the aspects.
Yeah. So it's more like, for this specific example, these replacement bots, it's more like different pieces, like different systems other than the HFSM to help the bot act as it acts. Because I wanted to do this specifically. This was my actual focus on the sample, because I have seen many HFSMs that does everything, like every possible thing for the bot is on there, and you have like hundreds and hundreds of states. Of course, this sometimes is the actual case that it might be needed, and that's fine. I'm saying it's wrong, but sometimes you can take a few things for the HFSM and deliver it to some other system. So you can decouple stuff, and then you can make the HFSM smaller, so it becomes better to manage it and to maintain it. So it's other systems actually.
So in this case, basically what you're telling us is that in addition to the HFSM, to manipulate these other aspects that you decoupled from it, you have other AI systems running in parallel, modifying the data.
Yes, and I will explain all of them after we skip the step. The next thing is to showcase the actual things that I have underneath besides of the HFSM.
Fantastic. And yes, okay, so there's definitely another part here is we've just talked about the AI being used to control, well, the bots, which is the common use case, but you can also use the features in the bot SDK to control aspects of the game itself. Is there anything that you'd like to show us in that area before we move on?
Yes, that's actually a nice thing, because we are getting more and more people saying that, hey, can I use the bot SDK for skills management? Can I use it for my game manager? So yes, I always also wanted to showcase this somehow, and I also did it here. So we have this state machine, which I call the coin grab manager. Coin grab is this game mode that we just played. So it's completely here in the hands of the designers to do everything. I mean, everything that their coders allow them to do with the gameplay. So we basically have the preparation step. It's the very beginning where you have the letters on the screen and you cannot move yet. The camera is lerping towards you. So you have the preparation. And here I basically followed a architecture of quantum events and signals. So I have two actions basically. And those actions can, in non-based, it can trigger any quantum events, meaning things for the view side, or it can trigger quantum signals, meaning that it will trigger logic on the simulation side. So this arena presentation tells, okay, show the letters, make the camera lerp, toggle controllers to false. This means, okay, nobody can move right now. So change timer to 15. So okay, the match will have 15 of duration when they get to 10 coins. And so on. So this is basically what I used. After the preparation, we check here. Okay, so did we spend already 4 seconds on the preparation? Did the introduction already finish? So then we can move to the gameplay itself. And the gameplay is basically we debug when it starts, and then we just idle and initialize a countdown when you have enough coins. And also we have here the spawn coin logic. I'm not gonna dive into this because it's simple enough. So we have the spawn coin loop, and I can basically enter here, and it's constantly spawning any prototype in any radius. So this can even be something else other than a coin. It can be used, for example, to spawn power-ups, etc. So yes, and then once the gameplay phase is over because somebody won, because the timer got less than 0, then we go to the finalization step where we just trigger a signal of game over. So okay, no collisions, nobody moves. Also a quantum event, so we tell the view side, okay, so show the end game UI, and also we have another quantum signal to toggle the controllers off so people won't be able to move and stuff like that. And when we debug, okay, the game is over. So yes, you can also use bot SDK for game management purposes, and this is an example of how to do it.
All right, so actually we have something here. On one hand, the chat comments that allowing designers to do something is definitely a very, strong wording towards, being a programmer-centric approach.
Yes.
But I think here we also have to remember that in quantum, unless you code it, it doesn't actually exist. Therefore, it is more about having implemented a feature that they can use in the bot SDK to some extent.
Yes, and it's also, it depends on taste. Like, I know that we're not saying that everybody should do this, but some teams can do and are doing it. So it's also not for only the designers. It also can make stuff faster for the coders. So for example, if I want to change the workflow here, I can just unlink stuff, or I can change it to point to something else. So it is nice for even prototyping very fast, because you can do things here. You just hit this compile button and you don't have to be reviewing the code logic. So it depends. It's based on taste. It's based on team. So it's not a rule, but it can be helpful.
So there's another comment we've gotten here is that, and we have heard that a lot from other people the first time they see bot SDK, of course, but they say, oh, it looks like visual scripting for quantum. What is your answer on that subject?
Yeah, so it is not like that, because the regular visual scripting that we can see sometimes is you can generate a circuit and it will be compiled into a actual code which is executed. But we are not dealing with code generation with bot SDK here. The only thing that we generate are data assets which are somehow linked between the states and etc. And this makes stuff happen, but it's not exactly generating code, so it's not the same visual scripting things that you can see on many Unity tools, for example. But yes, some people want to use it towards that way, so they can create very generic actions and very generic decisions, and use it to create visual coding. So it's possible. It's up to you, let's say.
Yeah. Also, I mean, to get back to like the leeway that you can afford with some of these things, it really depends on how it is designed originally, how these actions are, because the more open they are, the more flexible they are to be combined, and therefore you will allow the rest of your team, your non-programmers, to come up with things that you haven't envisioned. Now, this is both good and bad. It really depends on how these things are focused in this case. So
correct. Yeah,
either way it works, depends on which aspects you want to give free reign over.
Correct. And I also have to show just one more thing, because I think it will be relevant to this discussion. Just real quick, let me grab this to here and then play the game. The room will be filled with 5 bots, and we should be able to see them here. Just wait for Unity to load. Yeah, so we can see here 5 bots. If I click at any of those, what we can see here is that the debugger is reacting to whatever is happening. Let me put this here. So we can see real time the actual things that are happening. So it helps more with people being careful and being able to debug, because we do have a debugger showing what is happening. It shows the values on the blackboard also. So we're always worried about this too. So it makes it even better for even programmers who want to see it visually. We can also, I recently added the debug point feature where you can mark it as a breakpoint. You can put some debug message here. So whenever you enter on this state, these things will be triggered. Well, it's up to the team to know how to use it. We're just saying, okay, there is this tool. Use as you prefer.
Pretty cool. Now, something that I found new to me is like, of course, I actually hadn't seen the breakpoint yet, but you also appear to have different shades of blue, or basically going from black to blue during the debug state. Is there a different meaning between these two colors?
Yeah, so the brightest blue is the most recent transition. The darkest one are the 2 previous one to that. So you just know this was the exact transition that happened right now, and the others were the previous thing. So you have a better view of what is the current thing.
Awesome.
Okay, so I believe that we can go for the diagrams, so I can continue giving the overview, or do you have something else?
No, we have covered everything that has been in the chat so far. Of course, it has made some people want to jump into it already. But that is, of course, like the learning curve with quantum is a little bit higher than with fusion in this case, because there are so many new concepts you have to assimilate. Once you know them, it's absolutely fantastic.
Yeah, you don't want to make stuff in other way once you start doing it. So,
well, says you. I mean, after all, you're a little bit biased towards quantum. I think some people on our fusion team would disagree.
Yeah, yeah. Sorry about that, but yeah, I love quantum. I just love it so much. So I'm just saying it. Okay, so I'll proceed, right?
Yeah, move ahead.
So thanks a lot for all of the interaction, guys. Yours. So we have here this thing that will be, let's say, the last thing that we'll be doing today, which is analyze the actual things that are inside the sample, just to have a quick preview of you might be expecting to see. So let's start here on the top. We have the player joining and bots joining. So basically we have this player joining system that we some players, when they join, they will trigger a signal, and then it's represented here. So we create a character for that player. We assign a player ID. We assign also what is its team, and also we put it in the desired position on the spawners. So, but then the player joining system keeps waiting a few seconds, configurable, and then it will tell, okay, so it's already 2 seconds, and we have 3 spots left here. So players didn't join. So we should fill this room with bots, because then we can have a complete match. So it will get a random character, it will assign a random name for it, and so on. And in the end here, it will do this thing that I'm calling as botify. That's not a word, actually. It's just something that I usually use, which is transforming a non-bot character into a bot. And that basically means I will add an HFSM to it, I will add a navigation system to it, etc. So Botify just turns the thing into a bot. So that's the player joining system. You'll be able to see this and get it for your game also, the idea. It's a very simple concept, but it's very useful and easy to do with Quantum, filling the room with bots. And it's completely nice to have this on games that are on early stages of release, because you can then, okay, if the match is for 10 and you only got 5 players, then just put more 5 bots there, so players feel that they are having a good time with other people. I'm sorry, but with AI coding, we have to elude people here and there for the sake of the game. Other than that, we have.
So I think you bring up an interesting case. It's like there are two reasons here for bodifying your players, if you will. Like, on one is some people may drop out, whether it's rage quitting or bad connection or whatever else, and you still want the people in the actual game session being able to finish the match in the way it was meant to be played, rather than like you had a couple decades ago, if you were in the original Counter-Strike and then you were, in a team of 2 against 6, and well, your chances were not that good.
Yeah.
And the other thing is, sorry?
I know we do have that also implemented, the player replacement during the gameplay.
Yeah. And then, of course, as you mentioned already, like at the beginning, when you just launch your game, if you are very well known already and you have a massive player base on day one, you don't have issues populating a game session. But more often than not, especially for smaller developers and medium-sized developers, that original traction grows more organically. And you still want to be able to offer to those people who bought into your game on day one the experience that they were expecting, instead of having to stay in the queue for minutes at end without being able to feel a game session.
Yeah, that's crucial. That's why I think that not specifically bot SDK, but any type of AI from the very beginning, always worry about it. I mean, at least for most of the cases, already start doing stuff in a way that it will be easy to put bots in. So that was also my focus here. And it's well showcased here on the input polling graph. So let's see here what happens. We have this input system. Yeah.
About the players, and I think this is something we haven't actually mentioned on stream today yet, is that since this is deterministic, the bots are on all the devices, right? So compared to something like Pond that used to be client authoritative, if a player drops out, the other players don't lose their bots.
Yes, that's also important because by design, quantum AI, as you implement it on the simulation side, it is impossible for a player to lose all of the bots because somebody else disconnected. Because all of the bot simulation is done on everyone's device. So it doesn't matter if I'm alone, I'm just doing it on myself. I'm simulating all of the bots or whatever. So yes, we do not depend on this. And it's also really nice to have it possible. Thanks determinism and quantum. Okay, can I proceed with the input system?
Yeah, move ahead. We got one more question, but we'll get to that after we've gone through the different diagrams you have.
Okay. So we do have this input system here, and its main functionality is to update for every character that we have on the game, meaning that then for every player we first ask, is this a player? Because if it is a player, then we want probably to pull the input from him or her, and then basically from this part here we'll go to the top, and then okay, but if it's a player, is it still connected to the game? So because as we just talked, during the gameplay a player can drop out of the session, meaning that we have to replace that player. But well, if the player is connected, then yes, we just pull the input from the player. But if that player is not connected at the moment, then we can botify that character in runtime, and it takes just one tick, and then okay, that's just already a player, I mean a bot player. We have this, that's exactly what you're talking about before. And then if we botify the character, or if the character wasn't even a player at all, that's the case of the bots who enter to fill the room, then we just come here and pull the bot input instead. So it's either from the player if it's connected, etc., or either from the bot. And then with that input structure gathered, like with movement intention, attack intention, etc., we just apply it to the character. Now, the character, as you saw, can be anything. It can be the archer, the knight, or the spellcaster. It's agnostic to that, so the architecture just applies it. And it can even be something else that we'll be going to release on further updates. With the boss mode, we have like more AI and more minions, and a big boss will chase you, etc. But well, the architecture is unified. You can just get the input and insert on the character. So it's not like the bots have a very specific path that they take to do stuff that is super different from the players. No, it's the same path. They use the same method, same API. You just have to pull the input somehow. So yeah, you can apply it to anything, let's say. So that's what we have for polling input. So a combination of those two here makes you have bots for anywhere that you want. It's either a bot who will fill the room, or a bot who will take for a player who disconnected. So you just have bots to make the match safer for players, funny, etc. We also have here the applying the input. So, okay, we got it, and then we apply to the character, but how do we do it? So I'm just showing here a few different systems that we have. So we get the input, and then we apply to the character extension methods. Then the character will try to move with the top-down KCC. It will try to rotate, and it will try to use basic and special abilities. But then we have here a lock, because on Brawl Stars you have some locks, like once you start shooting, you have to keep rotated to that direction for a few seconds, or maybe your attack is so heavy that you have to stop moving for a few seconds and stuff like that. So we have, before actually moving and doing stuff, we first ask, okay, is this locked? If it is, then we don't do it. And then here we have the compute raw movement, etc. It's kind of too specific. I'm not sure. Yeah, I think I'll not deep dive on these unless people ask about it. But it's just, we get the input. If there is no blockage, we apply it to the different subsystems. That's how we apply input to stuff. So this is the AI building blocks. That's the thing that the person was asking for. So let's take a quick look here. Basically, as I was saying before, I encourage people to not do everything on the HFSM. If they can have other systems to take care of some specific stuff, they should, as to decouple stuff. So here we have the HFSM. In this case, it is the brain, because it considers stuff that is happening, and then it makes decisions, and then it is only capable of taking decisions. But after it decides what to do, it has to tell other systems, okay, this was my decision, please execute this. So there is a layer of indirection here. So the brain, which is the HFSM, uses the AI blackboard, which is the brain's memory, let's say. So the blackboard here in this case is used specifically by the HFSM, so it's a tied memory here. Memory that is per entity. So for example, who am I chasing at this moment? So we store the entity ref that we are chasing on the blackboard. So it's the memory from the HFSM itself to make the decisions. We also have the context steering. So this is basically, we want to go towards or backwards stuff, and it depends on what is happening on the game. If I'm following a character, okay, I can go straight to it, or I can go performing some evasive curves. And maybe also, if I'm chasing that person and then it shoots at me, I also want to steer away from that projectile. So it's a combination of vectors. We sum up everything that is interesting on that context, and then we normalize it so we get the actual desired direction for the AI, for the bot. So we have the context steering. The context steering itself uses the AI memory. It's yet another separate concept from the blackboard. So the AI memory is basically the body memory. So essentially, what do the body perceives from the game state that we have to store to use somehow. So for example, it is used to kind of simulate the human brain. This is something that I got the idea from the FPS template that we also have, that also has an awesome AI by Irka and Didi. So it's basically like this. The AI memory can forget stuff. within a timer. So for example, if you see a target, we can store it on the AI memory, and after a few seconds, it will forget about that target. So it kind of simulates the human brain, because we forget stuff after a few seconds, etc. And also in the sense that we sometimes take a few seconds to actually react to something, or milliseconds. So for example, there is a threat, and we put the threat on the AI memory so we can avoid it. But then we first check AI memory, is this already available for me, or did my reflexes didn't get it yet? So there is a slight time window where you cannot access that memory yet. So it serves also to create the reaction time. Like when I see something, I recognize it, it's on my memory, but did I already interpret it so I can react to it? So that's the job of the AI memory here. And the AI memory works with the AI sensors. We also have an architecture for that. It's not super complicated, but it's basically you create a data-driven approach for sensors. So for example, you have the eyes. The eyes will be responsible to see what is the closest target to me. So that's the one that I'm currently worried about. The ears, they can listen to stuff. I also have here the spider sense. That's how I would call it, because it's the threat sensor. So for example, if somebody shoots at you, the bot will recognize that as a threat and then will avoid it. So that's why I call it the spider sense, because you're specifically to avoid danger, specifically from attacks. And we also have a sensor for tactical judgment. So I'll deep dive in this in the next one. But it's basically every bot wants to know what is the tactic to go for now. So should I engage? Should I collect stuff or whatever? And that's done by the tactical judgment sensor. So that's also part of this. Of course, steering can be coupled to the navigation. So we can, for example, there's a complicated path to get somewhere. So instead of just trying to get there and getting it wrong, just activate the navigation agent for a few seconds, let it plan a path to there, and let's go on that path until we get to the target. So steering can or not be related to navigation. So there is this combination. And also the brain uses the level design markers. So I've placed a few things here and there to help the game understand what can be used, the bot, the brain actually. So let me just showcase here real quick on Unity some examples of markers, which can also be handy. We have let me see, hiding groups. I think that's, yeah. So for example, I pre-bake before the game actual start. I pre-bake the groups of grass that we have here. So this is group 0, this is group 1, this is group 3. This means basically that a bot can, hey, what is the closest group to me? Okay, so give me a specific grass piece that I can hide there. So for example, if a bot is running, let me get Gink here.
Actually, we had a question related to that. Is it possible to run a game that you have here only with bots?
Yeah, like for example, let me do it.
So yeah, we could actually see them, act on their own in this case.
Yeah, so I have here the array of players, and we have 2 seconds to fill the room. So after 2 seconds, the game will see, okay, so there is nobody here, then why is this weird? Okay, nobody here, so let's add a couple of random bots to act. Of course, the bots are not 100% perfect, because I don't have time to make something completely perfect, as this is just a sample, not a game to be released. But yeah, let's see those guys fighting. Oh, I got some. It's because I've activated the debugging, and it's giving me some errors, though. That's why it's stuttering. But yeah, that's essentially, you can run a game full of bots. We can see here that the mage prefers to attack from behind covers. And well, there's a lot going on. I should have put just 2 bots or something. But yeah, that's it. You can run only bots. Yes. So, okay. These.
Cool.
Yeah. Should I proceed?
Yeah, go ahead.
So this is the building blocks of AI. We also, very important here, the AI director. It's basically a per team, let's say, invisible strategies. So it will consider the game state and say, okay, currently we can do these type of strategies, and it will affect the box decisions, and I'll show how in a few. But yeah, those are the building blocks. So notice that I could have put all of this inside the HFSM to manage everything here, but it would be very, very hard to do the same thing without a HFSM that has hundreds of states and transitions. But yeah, it's kind of preference of mine. One of the last things here is the strategy and tactics. So we have the AI director. As I said, it will basically poll the game state and store relevant information from the team. So we want to know, okay, are we dying, or are the others dying, or are we both dying? This is important so we know if we want to fight at this moment, for example. This here is just coins. So it also will see on the state, okay, how many coins do we have on the game currently? Because if we have a lot of coins, then it's probably important for us to collect coins, as that's the objective of the game. And we also store some other stuff that I'm not deep dive here, the low score agents. So after polling the information, the AI director will judge what is the best strategy for now. So it's kind of hard-coded at the moment, but it can be used with utility theory very well, etc. So after taking the judgment, it will decide, okay, there are 3 strategies possible. We can either fight or score or run. Again, this is a strategy. This is not the tactic. So this is a higher level team synchronization. What do we want to do? We can do many things of those. But for example, if there is no coin on the scenario currently, then we obviously do not want to score. So anything related to score will be blocked by the AI director. So for every strategy, there is a couple of tactics. So if we are fighting, okay, so we can engage, which is just following a target, and we can ambush, which would be get hidden on a bush, and then when somebody gets close, attack. We can also score, meaning that we can collect coins, or we can, for example, add a suppression fire. Because if we're talking about strategy, scoring is not only getting things, it's also preventing others from getting things. So part of the score strategy can be do suppression fire at the coins, so nobody will be able to get there. And we also have the run. So you have 3 different ways of running. You have run, which is just get away as best as you can. You also have hide, which the character will find a group of bushes and then stay running inside of that group so he won't appear, so he's hiding. And we also have the take cover, which is mostly used by the spellcaster, because it will always try to take over here on those points, and so they can avoid people. So if I chase a spellcaster, it will be going in circles here because it knows that he needs cover, and that's it. So that's what the director does. It defines what are the strategies at the moment. Now, in parallel to the director, we have the tactical sensors, as I was speaking before, which is basically at this moment, the AI will analyze, okay, what is nice for me to do right now? Okay, we have a lot of coins here, and I also have a target there. So maybe I want to collect coins, or maybe I want to attack. So the agent will decide, okay, I want to do this, but if it's not important for the team because it's not part of the strategy, this means that it can be blocked by the director. So the agent will first ask, can I do this?
Disconnected.
Yeah. Reconnected. Perfect.
Yeah, so there's just one moment there where there's no data. Let's give it a second. Yep, we're back online.
Perfect. So continuing, the agent will say, can I collect? But if the AI director says, okay, you cannot collect because we are not scoring at the moment, it is not important for the team. So the director can check the strategies and then, okay, if it's allowed, then okay, yes, tell the brain, let's collect stuff. But then the director can also say, okay, no, that is not important right now because we are dying, we just need to survive, so we can just run. So then the agent will, okay, maybe I'll try another tactics, or just wait a few seconds before trying to change it again. So there is this intercommunication between the director and the agents. It's a strategies and tactics layer, and I mostly added this because before I had the director to actually allow people to do or not stuff, the bots were just too individual. They were like, they had no reason to be collecting stuff because, well, they already were winning, so they were risking themselves collecting. It was not needed. So I needed somebody to tell the bigger picture to the agents and allow or block them to do stuff. And that's the architecture that I've come with. And just a last thing here, actually we already talked about it. So it's the game manager system, which I also thought that it would be a nice addition. So yes, you can have a game manager, which is basically an update on a HFSM, which will trigger quantum signals, events, and actions, and make things happen. So yeah, we already talked about this one. And this,
so
yeah.
Like if we just circle back shortly to the AI director, this is something that has really been popularized by Resident Evil 4 and is not talked about much in multiplayer games, but it can be used, as Juan has shown already, to great effect to really pace out the game and make the bots more believable. So this is a concept that is really, really well fit for these kind of games as well.
Yeah, I believe that also Left 4 Dead used it a lot, if I'm not mistaken. It's like there is an AI director who knows what is the complete course, and it knows how many players are alive, how are their healths, and then it will instantiate zombies based on, okay, how can I create a tense situation, and sometimes allow people to breathe. So sometimes it will put more or less zombies based on the player's state and the amount of zombies that can be put in. So yes, the AI director can be used to coordinate a team or to change the game pacing, and it can communicate stuff to the brains, which would be the HFSM. So you see that it's a system that is self-sufficient, let's say, and it's not enough to do everything just on one place.
So we got a question that fits very well in here from one of our members over on the Photon Circle server, which was asking, since all of the behaviors that you have here, whether it is for the AI director, the HFSM, or anything else, are assets, this seems a really good candidate for basically creating new content, or new balanced content available through downloadable assets, rather than to have to update the whole executable of the game itself. What is your take on it? What are the the opportunities you see here, for instance, having more strategies, or versus having a new executable altogether?
Yeah, that's a nice observation. Because let me show you something. So I showed you that the player replacement HFSM has this config thing here, and we use its nodes to define stuff. We can drag and drop it here and use the value from this one. But as we are talking about, it is compiled into an asset. Now let me show you the asset. So it's on the export, it's on the AI config folder. So this is the player replacement HFSM. This is the config, the AI config that gets built when we compile this. So we have all of the default values here. So as you can see, for example, we have the error attack. So whenever a bot shoots, we add these errors, so they will not shoot exactly where you are, but maybe in front of you 1 unit, or behind you 1 unit, etc. So this makes bots more or less precise. So for example, we have here 3 variations of this. You can just reference it, and then we have the values that we can tweak per character. So this is the AI config for the spellcaster, the knight, and the archer. So as you can see here, let me get an example. The archer error is 1 because it's really hard to get a clear shot with the archer. But then the spellcaster one have 3 on his because it uses ballistic projectiles. It's much more easier to actually land stuff, meaning that we have different values and this is all assets. So as this person is saying, yes, we can, for example, update this specific asset for the spellcaster if we decided that, whoa, this character AI is too hard, so maybe we should increase this to 5. So yes, we can, in runtime, we can get it updated. There is some API on Quantum to actually allow it to be possible, to load assets in runtime, etc., to add it to the simulation in a deterministic way. So yes, that's possible. That's interesting.
Well, I think in this scenario, what they was rather thinking is, if you have already released your app and you go, oh, we should tweak a bit more the strategies or add new strategies. Can these be delivered via addressable bundles, for instance, rather than having to bake it into the executable?
Yeah, I believe so, because let me show you the HFSM. So it's all assets. Basically, everything is stored here. Let me get the other one. We have this asset and we have all of the actions and states here. So if you have this, you make a new version of this and you want to distribute that with a different logic, well, it's all assets. So yes, doable.
Fantastic.
Cool. I believe that, yeah, that's all that I had for today, at least from my side, because then the plans that will follow up with other streams, I don't know, let's say that we decide to explore this building block, and then on another one we get those 2, so we can actually deep dive on specifics and discuss specifics. Not sure if you still have questions.
Oh, let's give them a minute. So somebody says they have actually been using AI config to dynamically upgrade items in the game. And that's been really helpful. Have you considered that before?
Dynamically, what do you mean by dynamically? Just so you know if I get it right. Do you mean in runtime you change the reference to the asset, or are you downloading the data somehow and injecting it on the simulation? But no, I'd never thought about that. Like for items, interesting.
I mean, I could imagine seeing that as well. As you mentioned before, different difficulty levels, and if we had, a boss fight, that you'd swap out, like between the stages of the boss, the behavior that it has. Like, okay, stage 1 is this behavior. Bam, you defeated that part. You go to stage 2, and just instead of having an overcomplicated machine with all the different stages, you just have each stage being self-contained.
Yes, that's also, yeah. I've also seen that on some customers' HFSMs. Like they had a few states, and those states were very much reliable on config. And there were some Boolean configs to actually do not allow the boss to do this thing anymore. So it will ignore this if it's already on the hard level, and it won't do the silly stuff, it will do only the hard level stuff. So yes, that's all doable. It's all very interesting.
And so we have, the chat says, they were just changing the reference in here as you were suggesting.
Okay, yeah. That's also doable. It's one of the many ways that you can use to do it. Because yeah, it's just an asset ref, and changing asset refs is super cheap, so you can do it as many times as you want in runtime, and it's going to be completely fine. I didn't do this on this sample, but I do plan to maybe, for example, create a hard version of the spellcaster, which does not misses, for example, and then I can just tweak that once the spellcaster is dying, for example, because he's dying, so he's more concentrated or whatever, and so that's a possibility.
I would argue that, on the contrary, because they're about to die, they should be more erratic.
They're desperate. Yeah, that's another. That's possible. Yeah, that's a nice one.
All right. So what can we expect from the sample moving forward? Like, what people should actually be looking into that?
And so let's talk about versions. So this version, we focused on adding the coin grab mode and the HFSM. We did start to work with utility theory, and we also started to work on the boss battle mode. But as things started to get to, let's say, a little bit more complex, I didn't get the time to make everything perfect, and I wanted it to be as best as I could. So I removed the utility theory, and I removed the boss battle mode, because I prefer to release it as an update. We don't have to like launch this and never touch it anymore. So the idea is that yes, this is coin grab, this is HFSM. Next version, the plan is to have a boss mode with like 5 players playing together against a single boss, which will be controlled by a behavior tree. I will showcase the behavior tree, and this boss will have summons that every summon will have also a behavior tree. I want to make them a little bit cooperative, like they have to grab stuff from the scenario and deliver it to the boss, so they are a little bit more interesting. Okay, so the behavior tree. So that's a next plan. And I didn't plan yet much further from that, but I definitely want to showcase the utility theory here because it's also super interesting. I'm just deciding if I will use it just as a complement of the AI director, or if I will create an actual player replacement bot completely done with utility theory without HFSM. So I'm just still thinking. It depends also on what do people want, suggest, etc. Also, no, that's it for now. The gulp, I'm not sure yet. I also want to add the gulp here, but Jirka, one of our developers who did the gulp simulation code, he will deliver a fighting game sample with the gulp. So maybe I'll not showcase the gulp in this sample too soon. I'll give it less priority because we already have a separate sample for that. So yeah, those are the plans currently.
So, I mean, as per usual, I need to kind of state the usual Photon disclaimer. No ETA for any of these additional things.
Yes.
And also, I mean, I know you just said, you haven't really added it because it wasn't up to your standard. I know sometimes, it needs to get done. And I know everybody on the team always wants it to be 110% perfect. But at the same time, it's fine if it is not without any issues at all. And that is...
Yeah, I have to be more careful with my threshold of when should I release stuff. Yes.
But somebody just got back to the idea that you laid out before about upgrading at runtime, and somebody suggested, or rather was asking, whether it would be doable via addressable. So I think there are a couple of points here that we might have to clarify. Can you load addressables for the things from the bot SDK? I think we said that definitely that is possible, correct?
Yeah.
But keep in mind that addressables, or more specifically assets loaded in Quantum, need to be loaded deterministically, meaning in synchronicity. That means you can't just have that load asynchronously through addressables. That has still to be in line so that it's on all the clients are on the same state.
Yes.
The other aspect is, of course, downloading new content should happen before the game starts, because once again, we are in a deterministic context, meaning everybody needs to have all the information by the time the game starts.
Yeah, the details, specific details, I'm not very much aware because I didn't do yet much work with addressables in runtime and downloading data, etc. Piotr, one of our developers, tools developer, would be able to answer this in more details. He's reachable on our public Quantum server, So yeah, he would be the best person to get all of the details on that.
Though it's Friday evening here in Europe, so you'll have to wait till
Not
Monday.
today, yes, please Monday. This Monday.
All right. Well, I think we've covered a lot of ground here. Do you have anything that you will want to give people on the way to think about when it comes to bot SDK and AI and quantum?
Sorry, can you repeat? Not sure if I got it.
So before we wrap the stream up, do you have any tips or food for thought that you would like to give our viewers to reflect on over the weekend?
Nice question. Well, for those who already use the SDK, well, think about the separations that I showed here, because I know that the HFSM can be a big spaghetti sometimes, and we are sometimes also scared of fitting into more than one thing. So, well, if your HFSM is currently a monster of transitions, consider maybe putting some part of it on some different system. For those who do not use bot SDK yet, we have a few samples. We have a few things that you can look into before deciding to commit to it. And of course, you can also ping me wherever you find me, and I'll answer any question related to the SDK. Yeah, that's it. My main message here with this this sample is essentially, let's split in services, in tools. Let's not put everything in one or two systems. Let's split it and make the AI breathe.
I think that is great advice. Thank you.
So we are ready to wrap it up.
So I think so. The chat doesn't have any more questions. And I think, at least for today, we are out of things to present, aren't we?
Yeah, seems like. So let's just go back here to our Fireside talk. So let's wrap it up. Thanks everyone who watched and who interacted with us. Super cool to be talking to you in person for the first time. I know that I talk a lot with many bot SDK users, and they didn't know my face or my voice until now. So nice to meet you. Thanks, team, also for the amazing hostage. Super cool to have you here with me. And a very big and huge thanks for the testers, Ramon, Isaac, Daniel, you, Juarez, and an even bigger thank you for Juarez, who worked with me in all of this. I was mostly responsible for building up architecture ideas and taking care of everything AI related. But Juarez did put a lot of hard work to make this happen. He did so many things that wouldn't be the sample would not be launched today. I mean, next week if it wasn't for his very strong help. So thanks a lot, Juarez.
Awesome. And well, everybody, thanks for tuning in today. And as per usual, we're looking to do more Photon Insider streams as we move through the year. So if you have any special topic requests or just questions, of course, whether it's during the streams or after the streams, feel free to join us on Discord and ask us there.
Perfect. So see you next time.
See you next time, guys.